This is a lecture from Open Tuition. For the free lecture notes that go with this podcast, please visit opentuition.com. We're going to go through question 1 of the June 2011 paper F5 exam. So make sure you've got the question in front of you. And as always, go straight to the requirements. And under required it says A, construct a payoff table to show all the possible profit outcomes. Now as soon as you see that, for paper F5, it should be fairly obvious what's coming. The only time she asks you for this sort of payoff table is when you come on to part B. Decide the level of cement production the company should choose based on the following rules: Maximin, maximax, expected value. Justify your decision under each rule, showing all the necessary calculations. So there's where the bulk of the marks are, and it's almost entirely calculation. Part C, the written bit, 6 marks, describe Maximin and expected value rules. Well, that should be easy enough. Explaining when they might be used and the attitude of the decision makers who might use them. So it's all fairly standard. The main thing is to sort out this payoff table, and to do that we need to sort out what's happening. Questions of this sort, we're trying to make a decision. There are going to be various choices available to us, but the outcome is uncertain. So first of all, let's check what is going on. We're a company specialising in the manufacture of cement. When weather conditions are good, demand increases, more building work takes place. Last year it was so good, demand was so great that we're unable to meet demand. We're trying to work out the level of cement production for the coming year to maximise profits. We don't want to miss out on the opportunity to earn large profits by running out of cement again, but we don't want to be left with large quantities of the product unsold, since it deteriorates quickly and has to be disposed of. We'd receive the following estimates about the probable weather conditions and corresponding demand levels. So we told the weather, the probability, the demand, and immediately, as soon as you see probabilities, it's the demand that's uncertain. Each bag of cement sells for $9, costs $4. If it's unsold at the end of the year, it has to be disposed of at a cost of 50 cents a bag. We've decided to produce at one of the 3 production levels to match forecast demand. It's now to decide what level of production to select. And so now we're sorted. What is it we've got to choose? Our choice is the level of production. And with 3 choices, it's at one of the 3 levels to match forecast demand. Well, the forecast demands, we're either going to produce 350,000 or 280,000. Sorry, I'll leave a bit more space. 280 or 200. But that's our choice, the level of production. What is it that's uncertain? It's the demand. And the demand, it's going to be one of those 3 depending on the weather. Either 350,000, 280,000, 200,000. Now I always set my profit table up as a sort of matrix like this. For every combination we're going to work out the profit. But how you show the table's up to you. But the most important thing, and it's not hard in this one, is to decide what's uncertain and what's our choice. Always look for probabilities. The ones with probabilities are the ones that are uncertain. As to the choice, look at part B again. It says decide on the level of production. Well, that's our choice. Anyway, now let's work out the profits for each of these 1, 2, 3, 4, 5, 6, 7, these 9 outcomes. I'll do this one first, and what I always do is I show the workings for 2 in full, but because usually the thing's very repetitive, I tend to do the others on my calculator. It's up to you. If you need workings, show them, but don't waste time. But I'll do this one first of all. A. Here we're producing 350 and we're selling 350. So the profit we'll make will be 350,000 at the profit per unit. Profit per unit below that little demand table, we're selling at $9. We're selling at 9. The cost is 4. So $5 a unit. The profit therefore 350 at 5 is 1750. And I'm going to show it all in thousands. Otherwise, I'm wasting time, too many zeros. What else? I'll show this one in full. Here we produce 350, but we only sell 280. So the 280 we sell, I'll generate again $5 a unit. Which is what I can do that in my head. It's 1,400. But we've got 70 left over. And how much have they cost us? Well, two things. They cost us $4 to make. But in addition, if there are any unsold, they have to be disposed of at another cost of 50 cents. And so we're having to pay out 70 times $4.50. 315. Again, $4 to make them, another 50 cents to dispose of them. But that leaves us with a net 1085. Well, the rest of them I'm going to do on my calculator. I'm not going to show workings. But the next one, 200. We sell 200 at $5 profit each, which is $1 million. But then we have to subtract. There are 80 left over, and at $4.50 each, that leaves us with 640. What if we produce 280? Now then, be careful. If we produce 280, surely the most we can sell is 280. So when demand's 350, we can still only sell 280, and we make $5 a unit. Produce 280, and there's none left over. Sorry. So we just make the profit on those we sell. Produce 280, sell 280, again, 1,400. Produce 280 and sell 200. Well, 200 sold at $5 each is $1 million. Minus 80 left over at a cost of $4.50 each. I think I've made a mistake here. I get 640. I better go back and check this one. I should have shown workings after all. 200 sold at $5 a unit, we make 1,000. 150 left over at $4.50 each costs us 675. I am sorry. What does that come to? 325. So I'm sorry if I'd confused anybody, but I think we're right now. Finally, what happens if we produce 200? Well, of course, whatever happens, we'll only sell 200, and at $5 each. There's our profit. So that's part A, and even, excuse me, even with the delay for my silly mistake, I don't think that takes too long. Part B is making the decision. It wants us to do it using 3 rules. So first of all, Maximin. And I hear, because it says justify your decision, if you've learnt the rule, you'll know that you could write the answer almost straight down. But I think the best way of making sure it's clear what you're doing is to actually, well, see how I show it, to show it more or less in full. The point is, with 3 choices, we can either produce 350 units. I forgot the word, 280 or 200. With Maximin, we look for the minimum of the worst outcome. And the worst outcome, the minimum profit in each case, are these here, 325, 640 and 1,000. So 325, 640, 1,000. And having identified the worst outcome, we then pick the best of the worst. So the best of those, or the maximum, is a profit of 1,000 or 1,000,000 in fact. And therefore, we'll choose to produce 200 units. Okay, so that's Maximin. Second one, maximax. Well, again, same sort of idea, but for each of our choices, production of 350 units, 280 or 200. This time, we identify the best outcome in each case, or the maximum. And the best outcome from the profit table, well, if we produce 350, the best is 1,750, 280 is 1,400, 1,000. There's the maximum each case. 1,750, 1,400, 1,000. And the decision, we pick the best of those best outcomes. So the best or the maximum of the maximum is 1,750. And so under this criterion, we choose to produce 350 units. And sorry, I better add, it's 1,000. Make sure we get it right. Okay? Finally, now those two of course are only a mark each. The next one 4 marks as it does take slightly longer, but the expected value criteria. Here's where we bring in the probabilities. So we look at each in turn. First of all, if we produce 350 units, then there are 3 possible profits. 1,750, 1,085 and 325. The probabilities of those are the probabilities of the weather. 25%, 45, 30. So, it's harder for me going up and down the screen. Let's hope I remember right. 1,750, 1,085 and 325. There are the various profits for the weather being good, average or poor. The probabilities, 25% for good, 45, 30. The expected values, effectively the weighted average, multiply by the probabilities and add up. 1,750 times 25% is 437.5. 1,085 times 45%, 488.25. 325 times 30%. The total is 1023. Well, we'll do the same for each of them, and whichever's the higher of those is going to be the best. Now, is that in fact right? I keep making silly mistakes. I think I've made one there. 1,750 times 0.25. That's right. 1,085 times 0.45. Yes. 325 times 0.3. It's 97.5. The total, therefore, I hope this is right, 1023.25. Anyway, that's 350. Similarly for the others. So the next one was what? 280 units? And so the three possible outcomes, 14, 14 and 640. The probabilities, 25%, 45% and 30%. I hope you're checking me here. 350. 180. 192. This time, that can't possibly be right. Hey, dear, oh dear, oh dear. The second one has to be wrong. 1,400 times 0.25. 1,400 times 0.45. There we are. I'm going too fast and not pressing my calculator buttons well enough. I think that's a bit better. 1172. Incidentally, you could have saved a few seconds there. Instead of doing those two separately, you could simply have done 1,400 times 70%. Doesn't matter, same answer. Anyway, finally, 200 units. Well, here, of course, certainly there's no point in wasting time. Whatever happens, it gives us 1,000. So multiplying by the probabilities and adding up really is wasting time. That'll still come to 1,000. Well, finally our decision, whichever's the higher of those three, which is this one. And so we'll choose to produce 280 units. All right, well, that's sufficient for part B, so we've certainly passed the question, but make sure you do a decent part C. Incidentally, part B, even if something had gone wrong with your profits, I made a silly mistake at the beginning and had to change it. And obviously, when you're rushing in an exam, although overall the idea is simple enough, it's very easy to get some of these figures wrong. If you have, don't worry, you'll lose marks here, obviously, depending on how big a mistake it was. But provided your workings are clear, you'd still get full marks in part B for making the right decisions on your figures. Part C, it's irrelevant whether you've done the numbers or not. Describe the Maximin and expected value decision rules. Well, Maximin, it's really writing down in words what we just did. We identify the worst outcome for each choice of action. We choose that action that gives the best of the worst outcomes. So again, that's not doing much more than it's not doing much more than stating what we did above. That's describing it, But it says, when might it be used? Well, it might be used when we don't want to take the risk. I mean, I don't have to write a long essay, and I'm not going to, but appreciate we've chosen under Maximin to produce 200. That makes sure we are certain. Did we? Yes, sorry. It means we are certain to get at least 1,000. We can't possibly get less, but we've lost the chance of getting more. So we could have got a lot more, but we've been taking a risk. And that's the situation under which we might use it. Might be used when we're not prepared to take the risk of getting a lower outcome even though we have lost the chance of getting a better result. And that's especially relevant when there's a lot of money involved. If it's small amounts of money, then you're quite likely to take the risk. Even if you lose, you're not losing much. But if there are large amounts of money, why be greedy? It's better to be certain of getting 1 million than try and get more when you might get less. But particularly relevant, or especially relevant, when large amounts of money involved. Finally, though, the examiner did ask for 3 things: the attitude of decision makers, we're risk avoider. Well, that's sufficient for Maximin. The other one, though, was expected values. Well, again, describe it. So the expected values, you base the decision on the average return from each course of action, average outcome, and it's especially useful if it's a repeated decision. If this decision was going to have to keep being repeated, then sometimes you get more, sometimes you get less. On average, the expected value would be valid. However, it's not usually repeated. It's still used for one-off decisions. And the reason is, it's not saying it's perfect, but it does take into account the probabilities, which are certainly relevant for any decision maker, and the amounts involved. As far as the attitude to risk is concerned, we say they are risk neutral. They're basing it on the average. They're effectively ignoring the risk that it might be higher, it might be lower. And there we are. I've written it a tiny bit differently than I think the examiner did, although I think my answer is perhaps better. But certainly that would have got me full marks, or virtually full marks, even if not quite. Okay, that's the end of that one.